Welcome. My name is Govi Rao. I'm here with our CTO, Reyad Sawafta, with this webinar to talk about, how do we use Energy Blanket to deploy in buildings to keep buildings cool and drive energy efficiency. So welcome everyone, and thanks for joining us this afternoon. As you all know, this is being recorded. And if you have questions, please type them into the chat room and we'll have them answered as well as we go along here. So the agenda for today is to talk about introduce phase change briefly, and our core platform, BioPCM, and what we do. We'll also talk about the challenges in energy efficiency in buildings today, and some of the solutions we have, specifically BioPCM-based solutions, and address why now, why is it so critical for us to tackle this today in light of this overall evolving global policy, not just here in the US, but worldwide. And we'll spend time on the actual solution itself, BioPCM, the energy blanket, how it gets used, why, etc. So that's sort of what we'll talk about. So getting into the program here, and as I said again, if you have questions, please type them into the chat and we'll take them on as they come in. PCS, Waste Chain Solutions, we are an advanced materials company, and we focus on managing temperature and decarbonization. So, and both are interchangeable as well to some degree when you talk about buildings. And we actually want to be the leader. Our vision is to be a leader in smart materials, right? That impact the environment, the planet, the cost, energy efficiency, etc. Specifically, there are three areas that we are focused on. Energy efficiency and storage, where millions of square feet of our BioPCM-based product have been installed, largely in commercial, industrial buildings, school buildings, government buildings around the place, and we'll talk more in detail about the actual product itself. This is driving energy efficiency and to some degree energy storage as well. We also have solutions for the cold chain refrigeration and mobility industry. This is an evolving space where already for the last several years, I would say 7-8 years, millions of packages are being shipped using our product, our BioPCM-based product. And it happens every year. And this is increasing. It's on the rise as well. Not just in small packages, but also in trucks, in cold storage applications, etc. It's another very rapidly evolving market space. And then the third area that we focused on is telecom and data centers, where PCM-based solutions are used to manage energy, but also provide resiliency. This is in telecom shelters, data centers, etc., where it's not just you're lowering your HVAC usage, you're also providing resiliency of the ability to maintain temperature either in a data center or in a telecom shelter at the same level that you want it for an extended period of time, even after you've had a power failure, like it's happening right now in parts of the country and the world, or if your air conditioner blows out, your compressor blows out. So that's energy efficiency and resiliency. So these are some of the applications in the company. We've been doing this for several years. Now the question is, why has it become more crucial? So talking a little bit more about BioPCM, I mentioned BioPCM before here in a couple of places. So getting to a little bit more detail, this is a plant-based biodegradable solution. It's patent protected, obviously. It's proprietary to phase change solutions. It's tunable, and you can tune the temperature, density, viscosity, thermal conductivity, etc. So we can get it to perform where it has to perform, right? Whether it's in a small package, or it's in a room, or it's in a truck, doesn't matter. Or if it's in a cold storage facility, we can fine-tune that to the actual environment. It also, the phase change itself, traditionally it's either liquid to gel, or solid to liquid. In the case of BioPCM, we actually can have it shape stable as in solid to solid. So leakages are prevented. So even when it changes its phase, technically it stays solid, so it doesn't leak any further. So as an example, if you have a package like this with BioPCM inside, and God forbid it got punctured, using our material, there won't be any leak because it is shape stable. So it gives you that fungibility, the capability to put in multiple applications while making sure that you have the temperature requirements. You got it again. The end result is, because of the high thermal storage to weight ratio, we're also able to tune this to any temperature. Largely in refrigerator, you talk about we can go all the way to cryogenic, minus 70 degrees or 75 degrees, and all the way up to 175 degrees C as well. So the advantage here is it gives you a flexibility of operations. It obviously lowers the carbon footprint because it lowers your HVAC consumption, and it provides you the resiliency. And last but not least, it's sustainably sourced, non-toxic, non-corrosive, and non-flammable. So that's the core of what we do, just a BioPCM, the platform, and it opens up a variety of applications as we speak, specifically the market areas that I talked about. So why is this important now? Why are we talking about this now? Well, if you look at the current solutions in energy efficiency, and as you all have been maybe following, regulations are being increased, whether it's driven by cost or climate change or any other reason. Solutions like refrigeration, freezing, space heating, ventilation, these are all being used. They're okay, not quite to the level where we ought to be. And that's why energy efficiency becomes a huge factor contributing to it. And solutions like this, and Reyad will talk about this in greater detail as to how this actually makes an impact. If you take a building envelope, it accounts for about 30% of all energy consumed, whether it's commercial or residential building. And if we are able to make a difference there in the envelope itself, that's fantastic. And that's what we do. And we've been working with institutions worldwide to kind of provide that. Reyad, did you have anything to say onto this and add to this, Reyad, in terms of the added aspect of BioPCM-based solutions?
Thanks, Govi. Yeah, I think you covered most of the important points that we would like to add about the differentiation between the BioPCM platform and the competition. I think, as you indicated, our solutions are based on not only environmental friendly products, but also human friendly, where we don't take anything from the food chain, despite the fact our technology platform is based on plant-based materials and vegetable oils and their derivatives. From day one, we made a mandate that we will only take from the non-edible part of the food chain. And as you can imagine, 10 years ago, we made this decision. And today, with the supply chain challenges that are facing the world everywhere, with food and energy everywhere, I think the indication is clearly there. And I'm happy. I always like to emphasize this point that we take byproducts from the food chain manufacturing processes and repurpose them to solve other problems, rather than take virgin materials and introduce them in applications for energy and building structures and transportation.
Excellent. Thanks, Reyad. And that also stresses the fact that this can actually be a low-cost option when it comes to energy efficiency, right? Energy efficiency itself is a low cost for the global economy. And if you take BioPCM, it builds it in even a better solution there. So that's kind of where we had a thanks, Reyad. Thank you. So the why now is actually more prevalent than before. And if you take a look at building heating and cooling, so 40% of all of our use, comes from heat, right? 17% of all electricity used in healthcare and space heating and cooling, and you look at 50% of natural gas is also in healthcare for space heating and cooling. If we can impact that, that's at the infrastructure level without having to sort of maintain things on and on. That's a low cost alternative, and that's what we're talking about here using BioPCM. So the imperative is now for us to do it, and today these problems exist in spite of improving efficiency in HVAC, managing peak load management, etc. These challenges still persist. There is temperature instability in buildings, building spaces. Especially if we talk about pharmaceuticals, there's another big area there. Equipment efficiency, it's improving, and we can make that even better. And the best part about using something like thermal mass, which is BioPCM, inside of built environment, is it also provides occupancy comfort. So this, you reduce your hot cold calls, right? Well, you have a sophisticated HVAC system controls, can't quite get to use it really well. So that's the other advantage of using materials like thermal mass. It's passive, and oh, by the way, it's really easy to manage and maintain. So
Govi,
yeah,
if you don't mind, before we go to the next slide, if you go back to the comfort issue, I would like to emphasize another factor. As we all know, productivity and comfort are directly related or correlated. And there are multiple studies that have shown the productivity of workers, employees, humans, and in general in the workspace, that when you are providing comfortable temperature ranges, productivity goes high. The same, I think, is not only related into the industrial application, but imagine the students in the classroom at the high school and elementary school level, as well as at the university. So productivity is a big factor we often miss when we talk about some of the advantages that our solution can provide: resilience, energy saving, comfort, productivity. All of these factors coming together, they play an important role for the overall solution.
Yeah, thanks, Reyad. Thank you. Excellent point. And yeah, you're right. We don't talk about it as much, especially when it comes to the energy efficiency part of it. So I'm glad you brought that up in there. So let's emphasize that. We'll go into greater detail as well of examples where we have occupancy comfort as a big issue, whether it's in schools or hospitals or even in offices as well. Thanks, Reyad. So taking this further, why, energy efficiency, how we can address this, the current solutions that we have gets us halfway there, maybe partially there. So whether it's insulation, we get about, something close to 10%. Energy efficiency windows, you get about 15% and about 30% if you upgrades from HVAC solutions, right? You can do all of these, and it continues to improve. We're thrilled as well. And what we are working on with these solutions is adding this on and actually making it enhancing this with our solutions. If you take a look at insulation, we can provide additional augment the insulation by increasing the R value, but also providing better thermal comfort, right? Same thing with HVAC. We can improve HVAC efficiencies by 25-35%. And that's what the data has shown that we've been able to do for several years. So the BioPCM platform improves and amplifies the performance of current solutions, take that to the next level. So it becomes that it's cost efficient. And the other benefit is for something like a BioPCM based solution, it is maintenance free. Zero maintenance, no screws, no plumbing, no wiring. You put it there, it's thermal mass, and it does its job. That's the beautiful aspect of this stuff. So you don't have to spend any more money on maintenance. So just to kind of give you an idea, and as you can tell, the policy and incentives are growing around the world to kind of deploy some of these technologies, right? And that's why we believe that the timing is right. So if you take a look at the U.S. with the Inflation Reduction Act, the most recent one, the Homes Rebate Program gives you up to $8,000 for consumers who can lower their efficiency by doing upgrades. This is also in the commercial sector. If you take a look at other parts of the world, by the way, there's tremendous incentives even in New York. If you take a look at LN 97, there's penalties for not lowering your consumption. So products like the energy efficiency based ENRG Blanket based on BioPCM helps customers get to that level of compliance, whether it's an LL97 law or it is taking incentives, government subsidies, etc., to actually make efficiency upgrades. You can do this. Boston has a similar, sort of a incentive where they also have an ordinance to require buildings to lower their emissions. City after city, state after state are doing this. Using a product like ENRG Blanket with BioPCM gets us on that roadmap pretty quickly. And this is happening around the world. We joke sometimes, places like Kazakhstan that actually have huge consumption of standard fuel are actually driving policy and regulation to lower their consumption within 5 years. Very aggressive. Same thing is happening in Europe, Germany, UK, and other parts of Europe as well. So worldwide, this is becoming a major part, and some of the benefits of materials level change is that you can do this, across the world. And specifically here in the US, and we are focused a lot on the Inflation Reduction Act and energy efficiency for cost purposes. So that sets the stage for us to kind of get to the next level and saying, well, how can we actually get there? So with that in mind, I'm actually going to ask Reyad to talk a little bit about, maybe a little bit more about BioPCM, but more specifically about the ENRG Blanket, which is a product. So Reyad, if you want to get started and talk about this, it'll be great.
Thank you, Govi. As was summarized initially, so what we are trying here, what we are offering today, a number of products, and as you saw on some of the slides, it's not something that has yet to prove itself that it's being in use. So over the last few years, we have deployed millions and millions of square feet of these products, and in particular, today we are emphasizing and focusing on the ENRG Blanket. So the ENRG Blanket contains certain flavors, if you like, of our phase change materials that can be designed to provide multiple temperatures ranging from the sub-zero to room temperatures and higher. So this ENRG Blanket today is deployed in cold rooms and cold storage and schools and hospitals and banks and so on. So what is it? I'm going to show you a small cross section here in my hand. So the ENRG Blanket is the phase change material macro encapsulated between two layers of film. And inside these films, from the inside, we do have a gel material that is there that can be designed to provide the proper solution for the particular application. So if we're putting this in a building and we want to maintain the temperature in the building between 20 to 25 degrees C, we can choose a BioPCM that melts and freezes around either 20, 23, 25, 27. So how does it work? It's really a thermal sponge. It absorbs heat without becoming hot, and it releases heat without becoming cold. So imagine, just in a simple analogy, if you have a sponge and you dip that sponge in water, and it takes water without becoming wet, and you release it without it becoming dry. It acts exactly that way, but from a thermal perspective. So I like to refer to it as an active-passive system. It's active because it responds to the surrounding environment that it's being put in. And it's passive because, as Govi said, you don't need to plug it in anything. It doesn't require any maintenance. So as the temperature goes up or down, it responds on its own, within, of course, a certain capacity. So if it's at 25 degrees C, it will buffer somewhere between 23 and 27, or more in general terms, it would be between 20 and 30 degrees C, and so on. So what we have done, we manufactured this form factor for many years, and over the years, of course, we have made improvements, many improvements on the product, and today this product is being manufactured in different for different temperatures, in solid to solid, in solid to gel form. It meets all the fire requirements and the building codes in multiple states here. I think today we have installation in every single state in the United States, in about 38 countries worldwide. So what does it do? When you put this above a ceiling tile, or if you put this in the building envelope, it's a very easy installation. 2 to 3 people can go in and out from a building that's 5,000 square feet in less than 3 to 4 hours. Very simple. You lift the ceiling tile, you put one blanket. The blanket can be manufactured in different dimensions, 2 by 2 square feet or 2 by 4. Whatever the grid that you are installing above, we can match it accordingly. And you lift and you move. So from one spot, you install the blanket in all 4 directions, to the left, to the right, in front of you and behind you. And then you move to the next location, and they go on. And we have installed this with a tier 1 partner, where we did this in 1,500 buildings. And I think the average was less than 3 to 4 hours for building ranging from 4,000 to 6,000 square feet. So it's an easy passive installation. So what does it do for us? So one thing, when you put this thermal sponge or the energy blanket above a ceiling tile, the temperature inside the room, if it's a conference room or an office or any, I mean, even industrial or commercial or residential, usually in the morning, the temperature is around 70, 73 degrees Fahrenheit. As the sun goes higher and higher up in the sky, the temperature starts rising. The energy blanket is the thermal sponge that keeps absorbing all the heat being generated from external sources and from the internal sources. When we wake up, we turn our coffee machines, we take showers, we do breakfast. All of that heat generated within the building is being taken care of by the energy blanket until it absorbs, it reaches its maximum storage capacity. At that point, the mechanical system, since it is connected to the thermostat, it responds, it turns on, and then it stays on for a little bit until the thermostat is satisfied. At that time, if you just think about it for a second, if we are in an air conditioning mode, what's the temperature that comes out from the grid? It's 10 to 15 degrees C, or somewhere in the 55, 60 degrees Fahrenheit, in that range. So at that time, if you are putting a 73 or a 75 degree Fahrenheit energy blanket, it's going to be partially recharged again. So sorry, Govi, yes?
Yeah. So we don't need to change the set point, right?
We don't. The set point, you set it where you need it to be. If you're comfortable at 70 or 73, that's where the energy blanket that you put should be as close as possible to the desired comfort set point of the building. And in typically, we offer 23, 25, 27, and 23 degrees C, which is close to 73, 74, covers a temperature range of between 68 and 78 degrees Fahrenheit. So what the result of this system is that the mechanical system does not keep turn on and off. You are minimizing the number of on cycles. As you can see from the graph on the right, without the energy blanket installed in a structure, you have more cycles within an hour roughly. You are getting, in this case study, in about an hour and a half, you're getting 29 cycles. And if you look in the same for the same time interval, you are getting about 1/3 less roughly, and you see the distance or the spacing between the peaks is being maximized. So the saving is happening because you are having a longer off cycle. And for those of us who are familiar with how mechanical systems can consume energy, it's the same concept when you're driving a car. If you are moving at steady speed at the highway, your energy consumption per gallon, I mean the miles per gallon, is much better than you are stopping and going on and off inside a town. So the fact here that you are moving and the system is being kept running maybe for 20 seconds longer at the beginning, it's not costing you much more energy, because most of the cost is actually being taken care of by the first 15, 20 seconds, and the rest of it is free. You are just taking advantage of the inertia stored into the system. So if we were to quantify this and look at the table on the left, so how does the energy saving come? We affect the HVAC component of the energy saving building. We don't affect the percentage of energy consumed in lighting or in the refrigerator or in the stove and so on. So if we take this case study where we look at the number of cycles and you look at the BioPCM cycles per hour, you see there goes from 6 to 5 roughly reduction in this case. And if you look at and quantify all these numbers, you not only save energy, but you also can extend the life of the mechanical system because you are not stressing it, you are not making it cycle again and again. And these numbers can easily be quantified by studies that from mechanical engineering perspectives and equipment manufacturers. Another case study here. Go ahead, Govi, you have a question.
No, go ahead. I just want to say there's other examples of installations and like this bank site in Florida. Go ahead, Reyad. Right.
So this is a bank site in Florida. So in this is one out of 1,500 to 2,000 banks across the country in all climate zones. So we have installed the ENRG Blanket in the banking industry in every single state almost, and in every single climate zone and in many states. So let's look at the number for cooling and heating in this case. So this bank has the square footage with installed blanket was about 2,700 square feet, and the installation happened in 2019. So if we look at the consumption pre-ENRG Blanket kilowatt hour and post-ENRG Blanket, you will see there is an HVAC energy saving of about 20%, 19.84. And on the heating, you are talking about Florida now. You're not going to be worrying much about heating. So the heating contribution is much smaller. If you were to reverse this in somewhere like Boston or Alberta or other places, you would see that number as much as the cooling, if not higher. So a total in this case, we are introducing about 23%, 22.87. This is why we give a range. We usually, as you'll see from the different case studies, is somewhere between 20 to 35 reduction in the HVAC energy saving. There were some states and some case studies where we actually saw over 40, 45, but we are going to look at the average and the norm rather than the exception. So if you quantify and you look on the right, on the table on the right, you see again the HVAC cycles, and you see the correlation between the running time, the cycles per hour, and so on. Everything adds up when you look at it and trying to double check the savings from this perspective. However, I know there are people who say, well, these are theoretical examples. How can you quantify it? Today, and for the past 5 years, you could actually get access to your utility bill and look at your consumption online every hour. You see per hour, day after day, how much your consumption is being of energy that you are taking. And if you want, and if you have more sensors added, you could look even at the device level. However, the utilities also provide your consumption of 15-minute interval data. So if you don't have sensors attached to the HVAC and mechanical systems, you could look at your consumption on every 15 minutes or every 1 hour and look at it over the span of the 24 hours. And then you will see where the baseline stays when everybody's sleeping at 2, 3 a.m. in the morning, and then how it peaks during the day. And from there, you could normalize, and you see how this pattern is repeatable day after day. And then you normalize summer, winter, spring, and fall. And there are multiple checks that, according to certain standards, you would follow to quantify these savings. Next slide, please.
And Reyad, these numbers are based on MNV, based on measurement and verification.
Based on measurements, but I'm just generalizing. Today, you don't have to go and put sensors in every location where you install for managers who have a large portfolio of hundreds of sites, because we want to avoid the initial cost of MNV installations. This is a retail store in New York, and again, similar, about 2,000 square feet of an ENRG Blanket that you have, again, installation 2019, and the numbers show that you have 27% of HVAC energy saving. And if you go down the table, you could translate that, because this is based on an MNV, you are actually separating the HVAC consumption from the rest of the building. It comes to about 9% from the total building savings. And if once you do the math, and you have about 13% kilowatt demand reduction, and that's another factor, because the costs for energy at certain hours in the day are more than like if you are during peak demand. In states where you don't have solar, peak demands are 2 to 6, and in states where you have solar, now peak demand is when the sun goes down. So it varies from one location to another. Translate that saving from kilowatt hour to dollars, it comes to about $20,000 expected in 10-year energy saving in here, and then the ROI in this case is less than 3 years. It's about 2.7. And in other states like Hawaii and California and maybe Massachusetts, when the energy cost is higher, that number could be as little as a year or less.
Yeah. And that ROI is based on the utility cost, right, Reyad? So that's
yes.
varies, like you just said. And just a quick plug-in, those of you who have questions, if you're looking to type it, please do so in the Q&A section. So there's actually a QA box that's provided. Type in your questions there. For the chat room, that's maybe off. Just type into the Q&A. I'm sorry, Reyad. Go ahead, continue on.
Okay, can we go to the next slide, please?
Yep. This is the California savings. The bank site.
So the bank site in California, again, similar numbers. As you can see here, again, we are savings on the HVACs are very much similar from different climate zone. You have about 28% in the HVAC, 11% from the building. And again, the ROI is about 3 years. So very consistent across multiple climate zones. The next, again, in terms of the installations, as you note, one thing I missed to talk about is what percentage of coverage do you have? So usually what we do, we go and we say, okay, what's this available square footage for ceilings? And you take about 60% roughly installation of the space, because you have lights and you have sprinklers and other fixtures, the ceiling tile. So if you have a building of 4,000 square feet available area, times 60% roughly, you are talking about 2,400 square feet of energy blanket installed. And that's an easy thing to remember based on the density and the type of energy blanket we do. It's between 55 and 65 most of the cases.
Yeah, thank you. There's a question about a little while ago about the rate at which PCM absorbs or gives off BTUs, and then what delta T is required for optimum performance. And I know it's relative, so go ahead.
Yeah. So at this point, if let's take an example, a typical example where we are putting a 23 C phase change material in this energy blanket above the ceiling tile. If the temperature does not change at least 2 to 3 degrees above and below that design temperature, this means you are still in the comfort zone. Because if the thermostat is set at 23 and the temperature in the room is 21, the thermostat is not going to send a signal to the mechanical system to turn on because it's fully satisfied. Once it goes above that set point, then it sends that signal and the mechanical system turn on until the thermostat reaches the 73. So the way the energy blanket can be designed is to match the amount of phase change materials embedded inside or encapsulated inside these pouches that we talked about here per square foot, where you know what's the total consumptions, how many kilowatt hour are you consuming for mechanical system per square foot, and they are matched accordingly. So in order for the system to respond, we have to have about 2 to 3 degrees, at least more than 3 degrees above and below the transition temperature. The way the response of how many BTUs or what's the absorption and release, you could take, say, it's whatever you have in that system, you could easily release somewhere between 20 to 30% of the energy storage capacity into that system, into the space. So the energy blanket is designed to have about 35 BTU per square foot per cycle on the lower end, 55 for in the middle, 55 BTUs per square foot. And for energy intensive installations, we can go as high as 75 if you're talking about a greenhouse or a large conference room, but in typical offices at 20, 35 BTUs. So in this case, every cycle the system turns on and off, you could actually can exchange about 6 to 10 BTU per hour during the normal operation of that building.
Okay, thanks, Reyad. Thank you. And some takeaways
per
for
square
us,
foot, of course. I mean, and then you multiply that by the total square.
And which is why we do the sizing of the installation as well.
So in summary, our takeaways from this: the energy blanket is an easy install. very effective energy efficiency solution that can amplify the performance of incumbent insulations many times over, because you are providing thermal mass in addition to the insulation. And most of our installations of these blankets in multiple climate zones have shown that we can have up to 35% reduction in energy consumption, 25% reduction in HVAC cycling, and up to 20% reduction in HVAC runtime. And this is where then, if you add the direct saving and benefits on top of the resiliency that you get in case you lose power, the ENRG Blanket is going to keep that comfort zone and the other benefits we talked about earlier.
Thanks, Reyad. Thank you. So that sort of concludes. I want to make sure if people have other questions, you want to type into the QA. Pallavi, I don't know if the chat room can be opened, but let us know if people have any questions at this point. We can go back to some of the points we covered earlier as well.
Yes, the chat room should be open, but please feel free to type your questions into the chat room or into the Q&A box. We have another question as a follow-up asking how many BTUs or pounds can PCM store?
Each pound of PCM, again, depending on today, we do have PCM formulations that can have anywhere from 85, 90 BTU per pound of phase change material to about 120, 130 BTUs per pound of phase change material. And as I indicated, based on the need, we size how much material we put in an ENRG blanket on top of the building code requirements. If you are, as an example, what is the ceiling grid is being sized and approved to, we recommend 1/3 of a pound per square foot for most applications, except for spaces where you have more usage, such as training rooms and conference rooms and industrial application classrooms for schools, as an example, and meeting rooms and lobbies. Those we recommend 55 BTUs per square foot added in there. So the technology has evolved dramatically from the time we launched the product, that today we can double the energy density storage capacity of an ENRG blanket within the same volume.
So, Reyad, thank you. You mentioned, we talked a little bit about the ROI in the case study specifically. Probably worthwhile mentioning, what does it cost? People, I'm sure it's on people's minds, right? Yeah, it's great. It's oh my God, this is truly amazing. How much does it cost? Does it make sense? So can you give a little bit of an idea about, what does it cost? Again, I know it's dependent on utility, but go ahead.
Yeah. This is a great question. It comes all the time. And the cost of the ENRG blanket, really, you can look at it once the ROI is met within 3 years or less. I think it starts to compete very well with most of the conventional installation. However, to quantify that in dollars, ENRG blanket material-wise, the blanket itself, you could get it based on the loading of the energy density anywhere from about $2, $2.50 to $3, $4, depending on the concentration or the amount of phase change material inside it. However, installation costs will vary based on the locale where you install it, because there are union requirements, there are after-hour requirements. So if somebody can go and install it during working hours and without any restrictions from a union perspective or occupancy, that cost is going to be less than when you have to install it after hour under a specific requirement. So in general, it will be about $3.50, $4 max per square foot, based on union versus non-union installation. Installation cost, I would say, on average, is about 50 cents per square foot.
And in this case, when you say installations, if you're putting it above ceiling tiles,
above the ceiling,
you're just literally placing it on top. Like it's one
key solution, delivered, installed, cleaned, everything.
Employees
come the second morning, they don't know anybody was there the day before.
Exactly. That's the beauty of this, simplicity of the installation. So in talking about installation, Reyad, there's also a question about how about putting this into walls of commercial buildings? Because then you can build, thermally, walls that are actually thermally insulated in the building structure, but also this will be, can this replace insulation where, where there isn't a ceiling? Is that a possibility?
A great question. So first of all, insulation is an important part of the building code. So you cannot replace insulation because you have to do everything you do has to be within the building code requirement. So we do not recommend this to be used in place of insulation from that perspective. Can the phase change material in certain areas actually replace insulation? Absolutely it can, but we don't recommend it and we don't want it because this is in violation of the building codes almost everywhere in the world. So having said that, if you're having a new build and you are building a new house, and you want to put it in the walls, yes, it can easily be done. And you would have this external skin, then the insulation, the phase change material, the ENRG blanket comes, and then the sheetrock on the inside. And you don't have to put it in every wall. Again, the same concept we talked about 50–60% installation from a surface area coverage. If you put this in the walls, recommendation, you would put it in walls that face the sun. South, west in the evening, and northwest and southeast. The walls that face the sun, we put it there. However, if you look at buildings around the world, outside of, as an example, the United States and some European countries, many buildings are made out of concrete, and you don't even have a drop ceiling. So what do you do in this case? So the ENRG blanket lends itself really nicely to be integrated in fixtures, such as artwork, cubicles in the workspace, bedding in terms of the structure of wherever there is a space that you could put an ENRG blanket. As a matter of fact, this picture behind me here shows an example of an ENRG blanket being installed at the back of the picture, and we have multiple hotels and schools where this system is being installed as a temperature controlled in buildings where you don't have access to the ceiling wall. So in this, this is why it's a thermal sponge. You put it where it needs to be, as close as possible to a heat source, as in some cases. Ceiling applications are great because heat rises, so you could capture that heat. Or in the case of cold, if you are cooling the space, instead of being vented to the attic, you actually keep it below the space.
So Reyad, you gave a nice example of taking the ENRG blanket and finding other places that you can put into a built environment. So not just the ceiling tile, it can go in other places. Can you also just comment a little bit about, yeah, we get it, that's great. And given the fact that BioPCM is so fungible, are there other form factors besides the blanket? There's a question that came in that can also integrate BioPCM into built environment. Just some form factors that currently we actually have in the market, like as an example, the panel, right? We can talk about that.
So that's another very popular product because it comes in multiple form factors and different uses. It's actually a product that I like a lot because it lends itself for the applications. Like you could use the ENRG panel today in telecom shelters, in data centers, but you could also, the same ENRG panel is being utilized today also as a refrigeration panel, a freezer panel, where you could add it into your existing refrigerator and existing freezer underneath these shelves, or replace the shelves by these smart shelves in case you lose power, as we are talking today here in the southeastern part of the United States, where we are facing massive power interruptions. If instead of losing the content of the products that you have in your fridges, in your freezers, you could actually maintain that temperature where it needs to be, a 5 degrees C in a refrigerator or a minus 20 degrees C in a freezer for up to 24 hours without having to worry about what do I do with my food, or if it's a clinic, or if it's a university lab. That's at the device level. If you are talking about the building level, again, you could use the ENRG panel in place of the energy blanket above a ceiling tile or on the wall, because we have designed it to have its mounting systems that can easily be installed in and out without having to have any impact on the utility or the usage of the building, because you could slide it, you could move it vertical, horizontal, you could take it in and out to have access to the wall. And we have many of these, as you indicated in one of your slides. We have installed this in over 9,600 telecom sites.
Yeah, and thanks, Reyad. Thank you. And I think specifically also there's a question about using PCM in a refrigerated building. We actually have cases where we've used a similar form factor in a refrigerator warehouse.
In a refrigerated warehouse, or in a refrigerated truck, or in a truck, in a common truck that does not have refrigeration, where we do have a product where it comes on wheels and built in with air circulation system. You could load it on the truck, precondition, and we have shown that it was able to deliver the temperature requirement for a refrigerated product in a non-refrigerated truck from Chicago down to Miami, and during the entire trip. So you could have, we have installation in warehouses, also where they do a lot of fresh produce, where they need to keep the temperature of these different sections of the warehouse at different temperatures, especially vegetables or like banana, like must be kept around 10 to 15 degrees. 15 degrees is an ideal temperature range, while strawberries like to be kept around 4 degrees C. So the air conditioning system within the whole building can be one or multiple climate zone. However, the energy panel can be installed in sub-compartments within this building to provide and narrow the range of the temperature required for each product on its own.
Yeah, thanks, Reyad. And actually, the good news is, while it can also provide your thermal conducting, your capability inside to manage temperatures, you can also downsize your office HVAC system.
Correct.
That's it's again when you have the design capability. Go ahead.
Look at it from two perspectives. If you are designing a new building and you have the mechanical engineers and architect work from day one, you could start within the building with slightly downsizing the system and go from a 25 tonner to 20 or 15, something that's maybe more cost effective. The other thing, if you are doing it as an addition to an existing system, you are going to lower your maintenance costs and extending the life span of the existing system. So both ways you get the benefit by having less maintenance, less wear and tear, and extending the life of existing equipment, or downsizing it if you put enough thermal mass. Because if you take, we do have energy panels as an example, that by putting 100 panels in a special room, you could have equivalent to a few ton hours of cooling or heating if you store it properly to provide it when the demand requires it to be released.
Excellent. Thanks, Reyad. Thank you. Because that's the beauty of the product. These are all current products.
Current products, current application usage in multiple parts of the world.
Yep. And it's Friday, so if you want to be shipped on Monday, let us know. We can go to the website and place the orders. We actually do have all of these, again, current products. We make this. We are expecting this to be a high growth market, especially in the cold storage space, where you need to manage energy. Even if you're not building a new one, existing cold storage spaces, existing form factors can be done today, and we have enough data to show you. So this is all current products in there. That's years of data that actually shows that it actually works. So if people have other questions, let us know. But also,
I have one more comment to add, Govi, again, to give. Since we have launched our application in the cold chain industry, as you indicated in one of the slides, we actually we don't have millions, we have hundreds of millions of packages that have been delivered since the launch of the cold chain applications, because we provide these solutions that are, because the phase change material themselves, if they are thermally packaged correctly, and they can last for many years. The thermal performance of the BioPCM in the energy blanket is stable for over 100 years. We have done thermal cycling to exceed 36,500. However, the idea that today we are shipping medicine and vaccines from 24 hours to 120 hours, from one country to another, from one continent to another, exactly the same solution that's in the ENRG Blanket, yet each one with its own proper temperature design. So that also, since it's being used and in high massive amounts and quantities for different applications ranging from -65, -70 degrees C today to the 75 degrees C in heat pumps and others. So the technology has been fully vetted and implemented across multiple applications, hot and cold and moderate temperatures. So that's the last message. I think a message I would like to have our listeners go with. So this is a technology that has been in use now for over a decade, available in different form factors. You order today and we ship within the project requirements.
Yep. Excellent. Thanks, Reyad. Thank you. I'm seeing if there are any other questions in there. If not, as I said, this is the current product, current platform, a lot of data to show that it works across the space, from cold storage to schools, to government, to commercial offices, to buildings today. So we have information on our website. Please feel free to get in touch with any one of us. Also, if you have the requirements for sizing the project, it's all available on our website as well. Any other closing comments, questions?
No, I would like to thank everyone who took the time to attend this webinar. And if you have any questions, as Govi said, please feel free to reach out to us and we will be happy to provide more information.
Excellent. Thanks, Reyad. Thank you all again for participating and joining us. Be safe and have a great weekend. And for those of you in Ian's way, be safe.
Thank you. Have a good day.
Thanks, Reyad.